Okay, this is from section 6.5. No, actually, sorry, this is from section 6.1. This question here is from section 6.1. Solving the system of linear equations. So the way I solved this on the answer key for the review was I took this bottom equation here and rewrote it as y equals 2x plus 1. I just solved it for y. What I then did is, since y here equals 2x plus 1, that also means that this y in the first equation equals 2x plus 1. So I made a substitution into that y. So the top equation becomes x squared minus the substitution 2x plus 1, and that equals 2, which is the equation x squared minus 2x minus 1 equals 2. Subtract 2 on both sides and get x squared minus 2x minus 3 equals 0. Factoring that, you get x minus 3 and x plus 1, so the values of x are x equals 3 and x equals, let's try that again, x equals 3 and x equals negative 1. What we now need to do is use this equation for y to find the y value. So if x equals 3 and you plug that in for this x right here, 2 times 3 is 6 plus 1 is 7, so y equals 7. If x equals negative 1, 2 times negative 1 is negative 2, negative 2 plus 1 is negative 1, so y equals negative 1. So the solutions are 3, 7, and negative 1, negative 1. For question 25, this is from section 6.5, we need to graph both of these inequalities on the same graph. We need to find two things actually. We need to find where the shaded regions overlap, and we need to find the points where this graph passes through this graph. So I'm actually going to rewrite that top inequality as y is less than negative x squared plus 9. So that top inequality is a parabola because it contains a quadratic term. Since this plus 9 is not part of the squaring function, it's considered outside the function, therefore it's a vertical shift up 9 units. This minus sign flips the parabola upside down. So shifting up 9 units, the vertex is no longer the origin, the vertex is on the y-axis at positive 9. And the parabola is going to be facing upside down because of that minus sign in front. So to get the correct width, you would have to plug in values on either side of your vertex. So when x equals 1, for example, 1 squared is 1, times negative 1 is negative 1, negative 1 plus 9 is 8, so 1, 8 is on the graph. And because a parabola is symmetric, negative 1, 8 is on the graph. Because this is a less than or equal, this is just a less than and not a less than or equal to, it's a dotted line. And then we need to figure out where to shade. So I'm going to use a test point of 0, 0 to see if that satisfies the inequality. So if y is 0 and x is 0, we end up with the statement that 0 is less than 9. That is true, which means the test point's in the shaded area. So in the parabola, we're shading underneath. Now for the other one, y is greater than x plus 3, that's a linear inequality, it's a straight line. 3 is the y-intercept. The slope is the coefficient of x, which is 1, so up 1 over 1. And since it's an equal to inequality, it's just a solid line. And we can use the same test point, 0, 0, to see where we shade. So if x and y are both 0, we end up with the statement 0 is greater than or equal to 3. That's not true. So the test point we've chosen is not in the shaded area for the line, so the line is shaded above. So shading above the line, we see that the double shaded area would be under the parabola and above the line right here. This is the double shading. So that's what it means to graph the solution of the system of inequalities. That's this area underneath the parabola and above the line. Now when it says find the coordinates of all the vertices, that's actually finding these points where the line crosses or passes through the parabola. To do that, we need to make a system of equations instead of a system of inequalities. So it's going to be y equals negative x squared plus 9 and y equals x plus 3. If y equals negative x squared plus 9 and y also equals x plus 3, that means that these two expressions have to equal each other because they both equal the same variable y. So the equation can then be written as x squared plus 9 equals x plus 3. If we get one side equal to 0, we're going to have 0 equals x squared plus x minus 6. If we factor that, it's going to be x plus 3 and x minus 2, which means that x equals negative 3 and x equals positive 2. Now if x equals negative 3, and then we use this y equals equation here, negative 3 plus 3 means that y is equal to 0. If x is equal to positive 2, and we use this equation, 2 plus 3 means that y is equal to 5. So the coordinates of the vertices here are 2, 5. This one here is negative 3, 0.